Good morning, everyone. Okay, so today we are going to continue with more cases of simple harmonic motion. So, first of all, we are going to talk about systems where there are multiple springs. Okay, we are going to talk about systems where there are multiple springs. Let's start. Earlier, just to remind you that earlier we have learned that if you have a single spring and then a mass m attached to that spring, let's say spring constant is Ks, then we see that the force constant K is equal to Ks. Now it doesn't matter whether this is horizontal or vertical or in any other orientation, right? And then we found the time period as 2 pi under root m by K, but K is Ks, so you get something like this, right? Okay, so now we are going to see what happens when there is not just one spring but more than one. Okay, now there are different ways to have more than one spring. There are different ways to have more than one spring. Okay, so let's first of all take the case of series combination. Series combination of spring. Now, frankly, series combination means that the two are attached next to each other in the same line. So, let's say that here is some wall. With the wall, we have spring number 1 with spring constant K1, and then next to it we have another spring attached, let's say with spring constant K2, and then a mass m is attached. And this is, let's say, on a smooth floor. Understood the diagram? Okay? Right? So this is what is series combination of springs. So in this kind of situation, we are going to see what happens when this block makes oscillations, that is how much is the time period, how much is frequency, and all that. Okay. So let's say first of all that when this block from its mean position, let's say when this block from its mean position has some displacement x, okay? So do you realize that if you pull this, both the springs are going to get stretched? Yes or no? Both the springs will get stretched, right? So let's say that it's actually as follows. The point P comes over here. So we can say that when we pull this spring got extended by this much distance. You see, that's why the point P has moved that much. So let's say the first spring got extension x1. Similarly, the second spring got extension x2. Okay, now here it is not easy to show this. Let me be clear about that. It is not easy to show x2. Right? Okay, it is not easy to show x2. Reason is this line has moved. You get what I am saying? If you look at this line P, the point P is now no more over here. It has moved. Right? So basically what you could say though is that from P to this will be the natural length of spring 2 plus x2. Did you understand? Because second spring got extended by x2. Let me put that here clearly. Extension in first spring x1. Similarly, extension in second spring x2. Did you understand? So now this spring, the second spring here, has how much length? L2 plus x2. Clear? What is L2? Original length, of course, natural length. L2 is nothing but natural length. Okay? But ultimately, do you realize this very simple idea that because block has displaced, okay, block has displacement x, block has displacement x from mean position. Correct? Like I said, earlier B was here, now B is here. That means the block has displaced by x. Then do you realize that x should be equal to x1 plus x2? Yes or no? Yes or no? Do you realize that x should be equal to x1 plus x2? You know, it's extremely simple. If you take numbers, I think you'd get it immediately. It's that suppose there was some spring, let's say whose length was 10 centimeter. Let's say there is another spring whose length is 20 centimeter. Okay, and the block is here at 30 centimeter now. So if the first spring gets longer by 1 centimeter and second spring gets longer by, let's say, 3 centimeter, then do you realize that the block would actually move 4 centimeters towards the right side? Yes or no? If first spring gets longer by 1 and second by 3, then the block would move 4 centimeters. They will not act as one spring. That's what we are going to talk about. Aditya. Okay? They will act as one spring, that's right. But how exactly do we get that one spring? Okay? So if you have got two different springs which are attached to each other like this, then if they act as one spring, then what's going to happen? Okay, we'll get that immediately after we solve this particular point here. Okay, so x is x1 plus x2. Fine, that's clear. Okay, now what is x, what is x1 and what is x2? That's what we are going to put. Have a look at this. If instead of these two springs, let's say that we have only one spring. Let's say that we have only one spring. Okay, I was planning to draw the diagram over here, but anyways, I don't have enough springs. So if instead of two, suppose these two together would behave as only one spring. That is, we are talking about equivalent. Again, what is meaning of equivalent? Something that replaces the two together but behaves exactly in the same manner as these two behave. So this is K equivalent. Did you understand? Something that behaves exactly same as these two springs together, that is called equivalent. Clear? Meaning of equivalent is clear to you? Okay, so now what we'll say is, listen, because in equivalent case everything should be same. That is, if in equivalent case the block displaces by a distance x, if in equivalent case the block displaces by a distance x, then same thing should happen, right? So let's write down forces and all that. So first of all, here, if this is, while this is oscillating, the forces in both the springs will be same. That is, I am saying F1 will be equal to F2 equal to F. Reason, springs are connected to each other. You know, this is actually same sentence. This is actually same sentence as we had for strings. Let me make you recall, everybody, string. If you have a massless string, do you remember what happens in a massless string? What happens in a massless string? What is same everywhere in the massless string? What is same everywhere in the massless string? Very good. Tension is same everywhere. Well done, people. Okay, tension is same. So this is same case, because we generally talk about ideal springs. Whenever we say springs, we are considering them ideal, that is negligible mass and no loss or anything like that. So what happens is that because these springs are connected in the same line to each other, okay, the forces acting for them will be same. Okay, the forces, that is tension or pushing force, whichever, will be same everywhere. So F1 will be equal to F2 will be equal to, right? This is because of series combination. In the same line, just like massless strings, these strings also have same force everywhere. Now, if I use that over here in this equation, okay, if I use this relation in this equation, so instead of x, I can write f upon. Now this is interesting. For for x, that is total. Here also it is x. So do you realize that here also, if the same force F is applied, we can write F upon K equivalent as x. Reason for spring, F is equal to Kx, just by using magnitude. Yes or no? Clear or not clear? This is value of x. Clear or not clear? Then this is equal to x1 plus x. What is x1? F1 by K1, but F1 is same as F. I repeat, it was F1 by K1, but F1 is same as F. Similarly, F2 by K2, but F2 is also same as F, because the force is same everywhere. Because the force is same everywhere. Okay, what's cancelled? 1 by K equivalent is 1 by K1 plus 1 by K2 is what we get by cancelling the force. Okay? Understood this? What this means is, what's the meaning of this equation? Listen. It means that if you have got two springs and you attach them in series and then you put a block. If you got two springs, attach them in series and then you put a block and then you make it oscillate, then these two springs together behave as if there is only one spring like this, okay, and its equivalent spring constant will be given by this relation. Is it clear? Equivalent spring constant will be given by this relation. Okay? So Adisera, this is the answer to what you are saying. Right? Would these behave like one spring? Yes. But its spring constant can be found like this. So this is the equivalent spring constant for series. Right? It is the equivalent spring constant for series. Okay? Now, if you realize that it's going to behave just like one spring, okay, so now we don't need two, we need only one to understand. Correct? Okay, so I'm erasing these diagrams. Okay, we don't need two, we need only one to understand what is going on. So, if it's this kind of case where there is only one spring and this block is making oscillation, left, right, left, right, left, right, then do you realize that here also the force constant, I'm writing force clearly, it's okay even if you don't write it. Okay, the force constant will be equal to K equivalent. Yes or no? Do you understand this for this particular situation? Okay? So, therefore, time period of oscillation 2 pi under root m by force constant. But force constant is same as the equivalent K, that is equal to 2 pi under root m by. Okay, so here if you want, you can just multiply that here. Right? Another way to write this same thing would be K1 K2 upon K1 plus K2. Is this okay to everyone? Is this okay? You can also write this as K1 K2 upon K1 plus K2. Okay, just taking LCM and all that. So if I put it here, understood? Understood or not? Right? So this is what is going on, right? So this is the time period. So basically, when you connect two springs in series, then you cannot find time period just like this. Okay, just like K1 and K2. No, not only K1, not only K2, but some combination of K1 and K2 that is like this, right? Do you need to remember this? I'd say no, don't try to remember this, no need. But yes, remember this. Because if you remember that, you can directly jump to this step, isn't it? This is very easy. Because this is same as what we have learned earlier, that if there is a single spring, then you just put spring constant. Okay, what's the spring constant here for this spring? K equivalent. Easy. Okay, completely clear how to solve such questions? Alright. I'm erasing all the formula and all that on board, okay? Yeah. Now try this. Suppose three springs are attached, okay, and a block of mass 3m is here. First spring has spring constant k, second spring let's say has spring constant 3k, and third spring let's say has spring constant 6k, right? So for oscillations of the block, if time period is n pi root of m by k, if time period is n pi root of m by k, find n. Come on, hurry up. Ankita, that's because you see every physical situation is different, right? For resistors, the concepts or the the quantities like voltage and resistance and current, they are all related in a slightly different manner as they are here in case of spring, where you have a relation of three quantities F, K and X, isn't it? We have relation between these three quantities, and in resistances we have relation between these three quantities. So the relations are not always the same way, right? Okay, mathematically yes, it's a triangle that the three are connected, but the properties of quantities, that is in series, you see voltage can be added. If you remember what you are saying from 10th standard, in series voltage can be added, but in series force cannot be added, right? Instead the force will be F equal everywhere, right? Like I said while I was explaining. Okay, so that is what causes the difference. Understood? Yes, Gracie, that's what you have to do. 1 by K1, 1 by K2, like that. You have to keep adding. Okay? N equal to 2. Okay, Raj, I don't know. I'm giving you 1 minute more now, everyone. Come on, hurry up. 1 minute more. Okay, yeah. Hurry up, everybody. Come on. Time is running out. See, the first step is, like I said, to find out K equivalent. Okay, these are in series, correct or not? How to see whether that series is simple? They are in the same line, yes. Okay, with nothing in between. Between these two there is nothing. Between these two there is nothing. So series. Okay. So 1 by K equivalent is 1 by K plus 1 by 3K plus 1 by 6K. Okay. Right? Alright. Now, so this is equal to LCM of 3, 6 and 1 is 6. So here you get 6, here you get 2, here you get 1. Clear? So 9 by 6K is 1 by K equivalent. Therefore, K equivalent is 2K by 3 first. K equivalent is 2K by 3. Okay? Now, okay, Ria compared properly. So K equivalent is this. Now let's put it in the formula. It's that if instead of 3, you just have one equivalent spring. Okay, if you have one equivalent spring, then how much is time period? Time period is 2 pi under root mass upon K equivalent, correct? But be careful, mass is not m, mass is 3m. Understood everyone? Mass is not m, mass is 3m. Watch the diagrams or read the questions carefully always. So this is 2 pi under root 3m upon K equivalent. So 3m upon K equivalent means 2K here and into 3 multiplied over here. Is it fine? Okay. So now 3 into 3 is 9. I can put it outside in the square root. From the square root, so 6. And then this root 2 I can write separately so that it becomes this form. So again, I am getting 6 by root 2 pi root of m by k. Is this clear? I am getting 6 by root 2 pi root of m by k. Raj, do your calculations properly, don't guess. Okay, make sure you do the calculation twice. Don't make mistakes here. Okay, so 6 by root 2 pi root of m by k. But then why are you getting wrong answer? Earlier you guessed n is 2 just by looking at this, I know. You said n is 2 just by looking at this. No, it's not like that. Okay? So do your calculations carefully then, alright? Be careful, please. Don't make mistake like that. Yeah. So this is your answer. N is 6 by root 2 or 3 root 2. Understood everyone? The question is clear? Okay, now let's go to another possibility. Instead of springs in series, let's talk about springs in parallel now. Okay, which is actually a little bit easier. So part B, springs in parallel. Okay, that is parallel combination, you know, if you want to say parallel combination. What does that mean, or what does it look like in diagram? Well, like this. See, suppose there is a wall, there is a smooth floor. Let's say that there is a block of mass m, and it is attached by 2 springs like this. Did you understand? It is attached by 2 springs like this. Clear? This is called parallel. The springs are in parallel. Fine? Diagram clear? Now, if you would displace this block, let's say by some distance x from its mean position. So this dotted line indicates mean position, correct? This dotted line is M, mean position. So suppose you would extend the spring, let's say till here and till here. So do you agree that extensions are equal? Extensions are equal. Yes or no? Is this sentence clear to you, everyone? Extensions are equal. That is, if block moves the distance x, then that x is itself equal to extension x1 and x2. Displacement of block from mean position is going to be once again x equal to x1 equal to x. Fine. This is a story turned completely around. If you go back to the series, there the extensions were actually to be added to find displacement. Yes or no? We got this kind of relation in series, right? But in parallel, we're getting the extensions are equal. Okay? Right? One more thing. Let's draw FBD of this block. Okay? Suppose you draw FBD of this block. Okay? Very simple thing. Okay? You not have any problems at all whatsoever. Right? Okay? If you ignore the usual, mg and normal force. Okay? Don't worry about that. They don't bother us. There will be two forces on the left side. Clear? One from spring 1 and one from spring 2. Is it clear? One from spring 1 and one from spring 2. Fs1 and Fs2. Let me just draw it out here a little bit clearly. There will be two forces like this. Okay? Fs1 and Fs2. Everyone understood that? But एक बार जन्ने समझाऊँ so what say? Okay, okay, fine. Got it. Right. Yeah. So now, because there are two forces, do you realize that here the net force on the block? Okay, is equal to Fs1 plus Fs2 only in magnitude. I'm just writing this in magnitude. Let me just even remove this. Okay, only in magnitude. So what I mean to say is that here, if we consider equivalent case, what is meaning of equivalent once again? That instead of two springs, suppose there is only one spring that performs the same job or same work as these two together, right? So then do you realize it should be that there is only one spring and the block M is attached, and this will have spring constant K equivalent, right? So when you will displace it by some distance x, at that time the force acting will be same as this. Is it clear? Equivalent means should do the same thing as these two. So should give same force as these two. Clear or not clear? Should give same force as those two. Right? So now, if I will say that for equivalent case, we have F is equal to Fs1 plus Fs2. That is, here if the force acting is F, then this force should be same as Fs1 plus Fs2. So for F, let me write K equivalent into X using spring force formula. Okay? Using spring force formula. Elongation X. Spring constant K equivalent is equal to Fs1. What is Fs1? Spring force by the first spring. Okay? K1 x1 plus K2 x2. But what is x1? X1 is x. What is x2? x2 is also x. Absolutely clear? And again, the idea that elongation or extensions are equal. That's why here x will get cancelled. We will have K equivalent is equal to K1 plus K2. This is for what? Equivalent spring constant for parallel or in parallel. Clear? Okay, now hopefully you have understood the theory here, right? Okay, just revising things quickly, what we have here, how does the whole thing work? First of all, let me tell you about parallel because it's right over here on the board. In parallel, we are seeing that extensions are equal. Diagram helps tremendously, doesn't it? Drawing diagram makes you immediately realize that extensions are going to be same. If extensions are same, okay, then you write F is equivalent into x. But yes, forces are added. Why forces are added? Because two forces will now act on the block. Two forces will now be acting on the block. So total force is Fs1 plus Fs. So you put this equation and then just put spring constant relations, that is F equal to K into x, K into x, K into x. Got it? And you get this. Understood? So here extension same, forces are added, right? And this is the final formula. Compare that with series. It was all the other way around. In series, extensions were added. Forces were not added. Forces were equal. Am I right? Did you see it, everyone? I repeat, in series, extensions were added, x equal to x1 plus x2. And forces were not added, forces were equal. Right? So we got the other way around. Clear? Okay, fine. So time to solve a question for this as well. So suppose you would have two springs with spring constant 4k and 2k, right? And this block has mass m, right? Can you find frequency of oscillation of block, okay, given that there is a smooth flooding, right? Okay, so this is first one. Second one, if the block is pulled rightwards, that is towards the right side, by a distance a and release, find the speed with which it will find the speed when it is at mean position. Okay, come on. First part, very simple to do. Hurry up. Instead of time period, I am asking you frequency. No big deal, right? You know the relation between T and S. Okay, they were. Ria, read the question carefully. Look at the formula. Yes, good. No, Aditya, the answer is not right. Okay, Ron. Yes, Raj, it's correct. Yeah, Aditya, the frequency is correct. No, me. Some of you are making one slight mistake. Have a look here. The question is not time period. Right? The question is not time period, but suppose you want to still find it. Right? Time period formula is 2 pi under root m by k. Some of you are mixing the formula of frequency and time period. Be careful. Okay? With k, m and mk. You know, sometimes even I have this confusion. How to get out of it? I don't worry about all this. I remember this formula. K equal to m omega square. Right? K is equal to m omega square. Sometimes I forget that also. What to do? Don't worry, there are ways. Restoring force is minus kx, isn't it? And we know that acceleration in SHM is minus omega square x. Isn't it? So you know that A is equal to restoring force by m. So compare these two. M multiplied here. See? A is equal to m omega square. Right? That's how I do it sometimes. Right? I'm being very honest with you. What if you forget? You go back to basics, you get this. From here you can get all this easily. Okay? You can't afford to make mistake in exam, especially a silly mistake. Spend 20 seconds more, no problem, but get that plus 4. Okay? So here, frequency 1 by 2 pi under root. K will be 6k. Is that clear? K will be K equivalent, which will be 6k. Yes or no? And divided by m. Now what's the question further? The second question is what will be the speed when it comes to the mean position? What do you think? At mean position, how much is the speed in SHM? At mean position, what's the speed? At mean position, what is the speed? Yes, Ami, Divya, correct? Yes, omega into A. At mean position, the speed is omega into A, isn't it? Okay, so we pull it, we release it. So where you release, that will be amplitude. Do you agree? Do you realize or not? Where you release it, its speed will be 0, that will be amplitude, right? So V is equal to omega into A. So what is omega? 2 pi. Clear? The method is clear or not? Yeah, you can do that, Marvin, no problem. Okay, if you don't want to do it directly, find this, then take reciprocal, no problem. Alright, now I'm erasing the question and the solution. Okay? Well, there is one more combination. There is one more combination possible for springs, okay? But it's very similar to parallel. It is across the block. What I mean to say is like this. Suppose there are two walls This block of mass m, this is one spring, spring constant k1, another spring, spring constant k2. Right? Okay? So now, if you would move this block, let's say towards the right side, that is suppose there is small displacement. Okay? For displacement x of block towards the right side, we will have elongation or extension of spring 1 by x, and similarly compression of spring 2 by x. Do you understand this situation? Read the three sentences. Do you agree with that? If you move this 1 centimeter right side, if you move this 1 centimeter right side, spring 1 will get longer by 1 centimeter. Yes or no? If x is suppose 1 centimeter, you move this towards the right side by 1 centimeter, then this will become longer by 1 centimeter, spring 1. But spring 2 will become shorter by 1 centimeter. Yes or no? Common sense જેવું છે ને, અઘરું ન લાગ્યું ને? So, in this case now, if this has moved right side, spring 1 has got elongation. So do you agree that in that position the spring 1 will apply force towards left side? Yes or no? If you move this right side, spring 1 has got elongation. Instead of here, it will be here. So the spring has got elongated. Okay? Spring 1 will have force towards left side. What will be direction of spring force 2? Can you tell me, everyone, what will be the direction of spring force 2 in this situation? What will be direction of spring force 2? Okay, the correct answer is left side. Why so? Listen, if for the time being, let's even ignore this. Okay, we are clear about spring force 1. Now it's like this: you push it towards the right side, you displace it towards the right side. This will get compressed. So if it will get compressed, it will try to push this back. Yes or no? If this spring will get compressed, it will try to push it back. So Fs2 clear, left side. Fs2 clear or not? Very good. Okay. So, do you realize that this FPD is same as it was for parallel? Yes or no? Do you realize that FPD is same as it was for parallel? Okay? So, if I replace both by equivalent spring, okay, if suppose there was only one equivalent spring, then do you realize that we will get F equal to Fs1 plus Fs2, just like we had it in parallel? And instead of F, if I write K equivalent into X, I am not drawing everything again. And here you will get K1 X1, but X1 is X. And K2 X2, but once again X2 is X, because for second spring also the compression is X. Clear? And we get same relation. Okay? Why do we get same relation? Because two things happen. This FPD is just like it was for parallel. The second thing that happened is here. Do you realize that this is similar to parallel once again? In parallel both had same elongation, but here they have one has elongation x, the other has compression x, right? But still they are applying force in the same direction. So magnitudes are okay, right? Understood? Magnitudes are just like they were in the parallel case, right? No changes. You might have a question. In which direction should we put equivalent spring? No, that's if you have that question, it's a good question. Should we put equivalent spring here or should we put equivalent spring here? The answer is it doesn't matter. Whether you put it here or there, the behavior will be identical. I repeat, whether you put the equivalent spring on left side or right side, the behavior will be identical. Okay? So don't worry about that. So this is it. Clear? Any questions, anyone? Any questions? Especially here because I just went through with it because the maths is just the same. You don't need to worry about anything. Okay. Fine. So that's it for multiple springs. Okay. And once again, don't forget the orientation does not matter. So now, can you tell me what will be the time period of oscillation? What will be the time period of oscillation for this particular case? If this is displaced vertically and oscillating like this, can you tell me the time period? Can you tell me the time period? Time period of this particular case for oscillations up and down. Completed. First of all, these two they are in what do you think? Spring 1, spring 2, they are in spring 1 and spring 2, they are in they are in parallel. Gracie, you will get answers to your question, don't worry. Right? So these are parallel. Okay? And then what about this? This spring is across the block, isn't it? It behaves same as if it is in parallel, isn't it? Because the formula is similar. Yes or no? It behaves same as if it is in parallel. Do you agree with that? So, do you realize that effectively we can do it like this? Yes or no? We can do it like this. Okay, hopefully Gracie you got answer to your question because this is across the block, no problem. Horizontal, vertical, all that doesn't matter. The behavior will be same, right? So 2K parallel and this can also be considered to be like in parallel. Fine. So what will be K equivalent? 10K. Okay, the K equivalent is 10K. Now time period 2 pi under root m by K equivalent. So what's m? 5m, don't forget. And what is K equivalent? 10K. So just cancel that and you get 2 pi under root m by 2k, or if you want you can take root 2 out, so root 2 pi under root m by k. Understood? Right? So next time we will solve a few more questions like this where you have physical systems and they are doing oscillations. Right? Okay? Goodbye.